You just spent 2 videos learning how hash tables work. Here's the twist. You already know how sets work too, you just didn't realize it. A set is a hash table wearing a disguise, and once you see it, you can't unsee it. Sets show up constantly, removing duplicates from a list, checking membership instantly, comparing 2 collections. Today, we're showing exactly how sets reuse everything you already learned about hash tables, just stripped down to one job. A hash table stores key value pairs. A set only stores keys, no values attached. It's not tracking what does this map to, it's only tracking does this exist. Strip the values off a hash table and you've basically built a set. Since a set is built on the exact same hashing mechanism as a hash table, checking if something exists in a set uses the same hash function to jump straight to the right slot. No scanning the whole collection. That's why checking membership in a set is O1 on average. The same reasoning from the last 2 videos applies directly here. Here's a classic use case. Dump a list with duplicate values into a set, and the duplicates vanish automatically. Since every key in a set must be unique by definition, adding a value that already exists simply does nothing. No error, no duplicate. It just quietly stays as one entry. Sets also come with built-in operations for comparing collections. Union combines everything from both sets. Intersection finds only what's shared between them. Difference finds what's in one set but not the other. These map directly to real problems, like finding mutual friends between 2 users. That's an intersection. Reach for a set whenever your core question is, does this exist? Or are these unique? Not what value is attached to this. Checking if a username is taken, removing duplicate entries, finding common elements between 2 lists. All classic set use cases where you don't need the extra weight of key value pairs. Here's the mistake that trips people up in interviews. Reaching for an array or list to check, does this value exist? Then looping through every item to check it, that's O of n every single time. If you only care about existence or uniqueness, a set gives you that same answer in O of 1. This single swap is one of the most common instant optimization moments in real interview problems. A set is a hash table with the values stripped away, keeping only unique keys. That inherited hashing mechanism is exactly why checking membership is O1 on average, the same as hash table lookups. Use sets for uniqueness and existence checks. Use hash tables when you also need a value attached. This is video 14 of the full DevVerseX Data Structures and Algorithms course. Subscribe so you don't miss what builds on this next. Coming up, Trees Explained. The data structure quietly running behind every file system you've ever used.